Welcome everyone to another Silicon Labs product podcast. I'm excited today to have another topic that relates around the COVID pandemic. I'm joined today by David Hoover. David's the VP of the Advanced Technology Group at Connected Development, and they're a great resource. What they do is they help a lot of customers with their embedded wireless design needs. They work on both the designs and the certification processes a lot of customers struggle with. So thanks, Dave, for joining us today.
My pleasure, Kyle. Great to be here.
Yeah. I was first introduced to you from our Works With event, and you did a great session covering how to build a better contactless temperature sensor, and very timely with the COVID epidemic. I was wondering if you could spend some time today answering some questions that maybe might help our listeners understand what you did and how it might be a benefit to them.
Yeah, absolutely. Be happy to. It's not necessarily a pleasant topic, but it's one that I feel that we've done something that can help out a lot of people, both in our internal group, and then we've also made this entire solution open source. So if people want to see it and want to develop their own based on what we've done, that's available through a couple places. We could talk about that at the end.
All right, yeah, and I can put that into the podcast details so that people can have quick access to it. So let's just start at the highest level. So TTI was asked with Silicon Labs to participate in the Works With event, and we thought it was a great opportunity to do a reference design similar to this one. When you started researching temperature sensing and how it relates to the COVID epidemic, what did you find? What was some of the research you found?
Yeah, so maybe I can take a little bit of a step back and say why we were even looking at this in the first place. So as you said, we're a design services company. We work on embedded designs primarily. And back in March, when the whole COVID thing was starting to ramp up ways, our parent company, TTI, who's one of the largest distributors in the world, they own Mauser. They've got warehouses all over the place, over 100 different facilities across the globe. Obviously was looking for some way to get employees back into the facilities in a safe manner. And staying at home, unfortunately, in a lot of cases for our warehouse people, especially, just wasn't an option. We had to get them back in. We had to get them safely. So one of the things that we were looking at the time was what existed out there already that was being used to get people into facilities and it was primarily around temperatures. To answer your direct question, was how do you really screen people when they're coming into a facility to see if they're safe or not? Really, the only feasible way right now today is to use a temperature detection system. Pretty much everybody knows, right? If you go into a dentist, into a doctor's office, wherever it might be, that these the handheld guns are all over the place, right? So you can hold them up to your forehead and take a measurement. Unfortunately for our facilities, that didn't really serve the need that we wanted, because even those, you have to touch them. You have to have somebody taking the measurement, and that wasn't really acceptable. We needed something that was purely automated, that would be sitting on a desk or mounted on a wall. So the president of TTI came to us as the design services branch of TTI and said, hey, we're looking at this. What can you guys put together? And they were looking at something that was a desk mounted system that was, I think, over $2,000 per pop. For 100 different facilities, it wasn't really all that great. And frankly, it didn't even work all that well. So they came to us and said, hey, what can you guys come up with using the TTI line cards and what we've already got through our distribution channels that we could use to do this? So that was kind of the genesis of it. And get back to your question, the really only way that we came up to do it in a consistent manner was to use infrared and detect the employee's temperature as they were coming in.
Okay, and so once you had that task in front of you, you figured it was infrared temperature sensing. What did you start to break down as the first things that were required for the design, the components and the solutions that you added to the design?
Yeah, the first thing we had to do was figure out if it was even feasible, if this would even work. So we started off with some of the dev kits that we were able to get through. For the infrared sensor, it was a TE sensor that we grabbed a dev kit and we're looking at and seeing if we could actually get accurate measurements at the distances we wanted to, if it was consistent every time, things like that. So we pretty quickly got through that and said, yeah, this is feasible. And then we're looking at, what are all the other components that we need to put into the system to make an entire system out of it. Obviously, we had to think about the mechanical solution. How does it get mounted to the wall? How does it get mounted to the desk? ergonomics. How is it comfortable for somebody to come up and put their wrist next to it? We had to think about ways to make it so that it wouldn't be uncomfortable for people with different heights and different left-handed, right-handed, all that kind of good stuff had to be thought about. And then, of course, going back to the Silicon Labs side of things, we needed a microcontroller that we'd be able to use for the entire system. We were already familiar with Silicon Labs, had been using it for a lot of other different projects, so it was a natural fit, especially with the microcontrollers and the Bluetooth controllers that come from Silicon Labs.
Okay, so now you have your TE sensor and the Silicon Labs microcontrollers, your primary largest components. How did you put them together? Just for our audience, what are the main interconnects? How did you piece it together?
Yeah, so what we actually used and is still in our primary use case in most of the facilities was we started off with, and didn't just start off, we ended up with one of the Silicon Labs dev kits actually was perfect. So the Tiny Gecko dev kit had a display already on it, had all of the breakout pins already on it. So it was actually pretty easy to start there and say, okay, we didn't even have to really think about some of the things like the display and such was already built into the dev kit. It was also built into the Silicon Labs SDKs. So super easy to change it around and based on some of the examples that come out kind of out of the box. That was easy. So then we had the TE sensor, which had an I2C interface, which we basically connected up to the dev kit, to the Tiny Gecko dev kit. And we're able to get that hooked up and basically communicating. It's register reads and writes, so pretty typical type stuff for an I2C type sensor. Again, Silicon Labs does a great job of putting a lot of out-of-the-box type of drivers in place. So the I2C drivers themselves were mostly already there. Generic drivers. Of course, we had to put in the specific stuff to get the TE sensor up and going. And that was really the bulk of what we had to do from a software perspective, was actually write the specific drivers and the registers reads and writes and do the calibration and everything else we needed to do for the TE sensor. And then outside of all the electronic stuff, the other major challenge to the entire thing was the mechanics. So we had one of our engineers do an entire mechanical 3D printed design that we went through a couple of different iterations of that, tested that out on a lot of different people to see how it worked, and came up with a final design on that, which actually is pretty slick looking.
Yeah, I saw it's in the full training course that you gave at Works With. So people that are listening that want to see that full, images and the full design, you can log into the Works With. I'll put that in the details as well, and they can see the mechanical design, because that in our other courses that we held, that was one of the things that came back every time, was the mechanical designs nowadays are as important as the electrical designs that we're so commonly working on. So
Yeah, absolutely. Especially for something like this where it's going to be used, every day by a lot of different people. It just had to be very, very intuitive. And, it's silly things that you don't even really think about that, when we were first thinking about the design, we had the temperature sensor facing towards the person, but then they have to come up and put their wrist kind of at a weird angle to get it measured. So we went through a couple of different iterations and tests and determined that it was a lot better if it was on the side. So you just naturally put your hand right next to it. So it's the little things about that you go through a few different iterations of that and come up with a final design that makes sense for everybody.
yeah, and I also like the fact that you brought up that you started back in March, April with the Tiny Gecko, which is our microcontroller line. And then one of the benefits that we always tell our customers and our team about is that we build both microcontrollers and wireless solutions based on the same core. And so how did you find moving from the Tiny Gecko to our BG22, our Blue Gecko? What type of design challenges did you have with that, or how did you find that experience?
So, I mean, like you said, that was actually a really cool thing that comes with the consistency that comes with the SDKs and everything else that comes from Silicon Labs. It was actually very easy. So the core stuff, the APIs, all of the I2C stuff that I talked about was all the same, right? So porting the sensor over from one to the other was pretty straightforward. And then what that left is that we had to come up with the actual Bluetooth interface that how does the BG22, the Blue Gecko, communicate out to a smartphone? Obviously, that was going to be different between the microcontroller and the BG22. So that's where we really spent the most amount of time. But even that, there's a ton of tools that come out of the IDE, the Silicon Labs Simplicity Studio IDE. There's stuff that makes Bluetooth configuration pretty easy too. So we ended up using a health thermometer characteristic. And, again, that part of it was almost drag and drop in terms of saying, okay, enable that, get that going, and get it all attached to the smartphone. And then, of course, we had to spend some time. And then, in our case, we put an application over on an iOS device, a smartphone that communicated with it. But that was really the bulk of the time. It wasn't so much getting things ported from one platform to the other for the Silicon Labs side of things. That was actually pretty straightforward.
That's great. So what did you find to be the most difficult part of let's stick with the microcontroller and the wireless SoC. What did you find?
The whole thing, the entire solution, what was hardest?
What did you think was probably, if somebody's going to start tackling this type of a project, what did you find was, and again, for connected development as a service, what was the hardest thing that you think you could add to other customers as a benefit to working with you?
Yeah, well, I'll talk a little bit about the major challenge, and it continues to this day of the detection solution that we came up with. It's biology more than anything else, and I actually mentioned this in the Works With event too, and made a little bit of a big deal out of it. But different people have different temperature characteristics, and unfortunately, I know this all too well now from dealing with this over the past few months. But some people's wrists are just naturally colder than others. Some people have a difference between their forehead and their wrist that's different than other people. So how to deal with those different people and how to get a somewhat consistent measurement across different biology of different people was really the most difficult thing out of any of this. And that's it's not so much of an electrical challenge. It's more how do you deal with trying to make it so that it will work for everybody. We ended up doing some things that were kind of interesting, that we put in some adaptive measurement techniques that if it wasn't immediately detecting a cold-blooded person, I'll say that, yeah, cold-blooded, but we would adapt the thresholds and bring them down a little bit if he wasn't immediately detecting somebody's temperature. So that was really probably the most challenging thing of the whole thing, was understanding how different people were showing up on an infrared measurement technique.
It sounds great. I mean, again, if you watch the full Works With course, there's a lot of detail. You guys did a lot of work, and as you mentioned, it's something that people can evaluate pretty quickly with the starter kits from Silicon Labs, the sensors from TTI. They can start mocking it up and seeing with your example code how to get these things running. So great work by you and your team. How did it end up working out? You mentioned you've had iterations of it, but how's it working out in the offices, in the TTI offices?
Yeah, so like I mentioned, shutting down the offices in some cases just wasn't an option. So the call was to put one in every single TTI branch and facility. And that's been rolled out. Actually, they finished rolling it out last month. So we've got 60, I believe, total units. We built 100, and I think 60 have been worldwide. So they're all over the place now. There's some in Germany, there's some in Korea, obviously a lot of here in the United States. So they're all over the place. So far, it's working great. Basically, we've got one in our office. So every day, whenever anybody who does need to come into the office does, it's about a 2-minute exercise, maybe even less than that. You just come in, you put your wrist next to it, it automatically detects you, says you're safe or you're not safe, write it down on a little piece of paper, and you're done. So it's been really good. It's allowed at least some peace of mind for people coming back into the office. And in some states, it's a requirement, right? You don't even have a choice, that you need some kind of a monitoring system. Again, the cool thing about it from our perspective is that it's a fixed installation, completely no touch, not a single thing that you need to touch in the entire system. So that's a little bit different than the guns and stuff that you pick up and you can measure with today. So it's definitely an advantage, makes it super easy.
Yeah, I drop my kids off at their events, their trainings, and their sporting events.
Yeah.
And you walk in the front door and people jump at you with that gun in their hand, and they're not doing what they're supposed. They're not holding the class. They're being taken away from their things because, to your point, somebody has to hold it, and then you have that whole transfer of who's holding the gun, and so it definitely see the need and the improvement that stationary device will add. So that's great work.
Yeah, and right when I was starting to work on this, I started noticing more about those guns. And when I was going into a dentist office or whatever, I would be paying more attention. I would be asking them, how's the accuracy on this and all that kind of stuff. And one case that I saw, in one of the places I had to go is somebody was holding that gun up and had to do like 5 different measurements on somebody because they just weren't showing up. So it's the same kind of thing, that there's some tricks to all this, but hopefully we can make it a little bit easier for everybody out there and do a little bit of good in the world.
Well, this was obviously something that you did to showcase your ability to help customers with challenging designs. How can our listeners, if they want to engage a customer, or if they are a customer and want to engage a design services outfit like yourself, how do they engage connected development? What's the best way?
Yeah, so you can go to our website. It's www.connecteddev.com, and there's easy ways to contact us through there. So I think my contact details are up on the Works With event. Certainly, anybody can contact me anytime if they've got a project they want to work on, want to get some help out with some design services, or need help with certifying their device, getting through regulatory. That's kind of our bread and butter stuff we do all day long.
Well, again, thanks, Dave, for joining this afternoon and sharing your experience with this design. I'm sure our listeners learned quite a bit about the contactless temperature sensor and the challenges that you faced with it. So thanks a lot.
Thanks, Kyle. Appreciate being on.
Sure. And I'd like to thank our listeners for the time they're spending listening to our podcast. Until our next episode, stay safe, everyone.